Welcome back to the Math Professors. Our YouTube channel covers topics that can be found in any college math class. So if you like the free content and would like to help us grow our channel, please consider liking, subscribing, and sharing. So what I want to do for you today is integrate the tangent cubed of x dx. And I found this by integrating something we did in another video. So let's do this. What about the integral of the secant squared of x times the tangent of x dx? Now, the way I did this before is I did it with a not a u substitution, but a by part substitution. I did it both ways. But this also sets up for a u substitution, so you can do this, this antiderivative multiple ways. So let's do this as a u substitution since I already did it by parts. So if I let u equal to the tangent of x, then the differential du is going to be equal to the secant squared of x dx. So this thing simplifies to the integral of just u du. Now, if I take the antiderivative in terms of u, I'm going to get u squared over 2 plus c, giving me the exact same answer that I had before, which is going to be equal to the tangent squared of x all over 2 plus c. All right. Now, what I know is that, this integral is equal to that. So this is the integral of the secant squared of x times the tangent of x dx. And I know that the secant squared, there's a Pythagorean theorem that relates us to the tangent squared, so we'll do it over here. What about the sine squared of x plus cosine squared of x is equal to 1? Now, if I divide everything by cosine squared of x, both sides, this is going to give us tangent squared of x plus 1 is equal to the secant squared of x. So I'm going to use the fact that secant squared is equal to the tangent squared of x plus 1. So this is the same thing as the integral of the tangent squared of x plus 1 times the tangent of x dx is equal to the tangent squared of x all over 2 plus c. All right, distributing, I know that this is going to be equal to the integral of the tangent cubed of x. I'm going to say dx using linearity, and then the integral of the tangent of x dx, which is going to be equal to the tangent squared of x all over 2 plus c, which is where I figured out, hey, then we actually know how to find this, because I know what this, the right-hand side is equal to, and I also know how to integrate the tangent of x dx. So this sets up for a nice substitution. So let's go back up to here and solve it for the integral of the tangent cubed of x. So this is going to be equal to the tangent squared of x over 2 minus this integral. So the tangent cubed of x is going to be equal to the tangent squared of x all over 2 minus the integral of the tangent of x dx plus c. So now the way you integrate the tangent of x is you use a u substitution. So the tangent squared of x over 2. The way this is going to be done is this is going to be equal to the integral of the sine of x over cosine of x dx plus c. So for this, you're going to do u is going to be equal to the denominator, and du is going to be the derivative of the cosine with the differential. So this is going to be minus the sine of x dx. Now I don't need negative sine of x, I need positive sine of x, so multiply both sides by -1. So this piece right here is going to be minus the integral of minus 1 over u du. Now, pulling out that negative sign, this is going to be plus the integral of 1 over u du. And then putting all the stuff back in here. So this is going to be tangent squared of x over 2 plus c. Now, the integral of this thing is going to be the natural log of the absolute value of u, where u is going to be equal to the cosine of x. So finally, if I'm going to call this my target integral, the integral of the tangent cubed, the integral of the tangent cubed is going to be equal to the tangent squared of x all over 2 plus the natural log of the cosine of x plus c. Again, so if you like the videos, please consider liking, subscribing, and sharing. Thank you.